Now that you've completed the CP version of this explanation, we do need to add a couple of things. I know it makes more sense if this had been all comprehensive, but I wasn't going to re-record the video, so sorry about that. So this is what you have in essence. It may not look exactly like this because I've made this drawing several times, but something to go back and add for IB is not only is the starch being digested by amylase into monosaccharides, but keep in mind what makes up starch. So over here I would break starch into two components. Remember, we have amylose and we have amylopectin. So remember, one of these has more 1,4 bonds. We've got some with 1,4 and 1,6 bonds. So, but keep in mind, starch is made up of both of these. And your mouth will start chemically. This is chemical digestion. Oops, I say that right here. Good. Chemical digestion. Start that as well as your mechanical digestion. So as we kind of track on down, everything else here is kind of going the same. One thing we do need to add over here is at the pancreas. So if at any time I'm going too fast, just pause the video so that you can draw what you need to draw. We need to talk about these digestive enzymes in this bicarbonate solution because IB does need you to know that inside this pancreas, I'm going to take one of these guys here. I'm going to take one of those and we're going to blow them up bigger. And so we're going to add this to our drawing. So I'm just going to kind of make this kind of weird balloon-like structure. And I'm going to kind of turn this all in. I'm going to line it again so we can make our cells. So yes, our cells are square, but they're so much easier to draw that way. Right, so this is considered an acinus. And these are acinar cells. So this is a space, a lumen, this is the space inside here that connects to this pancreatic duct. And these are the cells making up this structure here. So why this is important is because these are the ones, these cells, make the digestive enzymes. These cells go through, these cells go through a whole bunch of protein synthesis, making all the different digestive enzymes, amylase, proteases, lipases, nucleases, tons and tons of digestive enzymes, and they will secrete those enzymes into this space. So they're going to have lots of protein synthesis, enzymes end up in this space, and as these enzymes are going to then make their way this way, what are these cells making? These cells make the bicarbonate solution. I'm going to abbreviate this for space. So these cells lining the street, I think of this as kind of like a cul-de-sac. The houses in the cul-de-sac are making the digestive enzymes. The street, these cells here are making the bicarbonate solution. So now all of these enzymes are coated and surrounded and protected by an alkaline solution so that when they travel down the pancreatic duct and end up here in the duodenum of the small intestine where they meet chyme, it will neutralize that acid. And so you do need to know specifically in an acinus or in these acinar cells who's making what. You'll need to know that these make bicarbonate solution and that these make digestive enzymes. All right, so down here we talk about finishing chemical digestion. It's all finished, everything's done, thank goodness. And now we're going to go into absorption. And the absorption piece I need you to add just a little bit here. So when we have our amino acids and our monosaccharides, these are absorbed through both active and passive transport. Your notes contain the specifics of where's the active transport and what types of passive transport, and you will need to know those details. But just as a reminder, when you're looking at a big overview, that there's both processes involved here. Whereas when you look at your monoglyceride and fatty acid chain, so I have this as glycerol, IB is going to note this as a monoglyceride and fatty acid chains, because in reality 2 fatty acid chains come off, we have a glycerol with 1 fatty acid chain still on it. When this is absorbed, it is going to go through simple diffusion. It's just going to be through diffusion. Hydrophobic can get through the hydrophobic cell, inner part of that lipid bilayer of the cell membrane. So these guys can just diffuse right on through this cell lining here. So that's the absorption piece we're talking about. Well, how do we get through this epithelial cell, from this space through this epithelial cell to get into the inside of the villi? So now we've kind of added a little bit more detail in terms of absorption. The last piece is, once these things have absorbed into the blood and we have all of our sugars and whatnot, keep in mind that as all of these nutrients are heading back up, yes, to the heart, so we had, remember, in a circulatory system, blood would come out to the digestive system as oxygenated, and it's going to come back deoxygenated to the heart, but it's going to go through the hepatic portal vein in order to do that. So when this comes back through the hepatic portal vein, coming up to our liver, as it goes through the liver, remember, excess glucose is converted, there's some series of stuff in there, but we don't need to know the detail, into glycogen. And that's for storage. And so what that's going to do is that is going to decrease our blood glucose levels. Oops, learning to spell. All right, and we'll talk about how insulin helps with this process in a future unit. And then, of course, obviously, we continue back to the inferior vena cava, back up to the heart, etc. All right, so that is that little bit of extra detail that was not in my CPE video. So if you have any questions, make sure you reach out. Have a good day.